Okay, in this video I'm going to show you how you can emulate or virtualize an environment where we have some Cisco 7200 routers running telephony services, and we're also going to simulate two Cisco VoIP phones, and we're going to link those together, and I'm also going to show you the two phones calling each other at the end of the video. So first off, in order to virtualize our virtual machines, we need a hypervisor. In this video, I'm going to be using VirtualBox running on my host, which is Linux Mint 20, but really you can be using any type of hypervisor. For the host running virtualizing the Cisco routers, I'm going to be virtualizing another instance of Linux Mint. This is 18.3 in this video. I gave it 4 GB. Obviously you can use any version and you can give it more RAM as well. For the Cisco phones themselves, we're going to be running the Cisco IP communicator, and this is a Windows application. So for this I have two Windows 10 VMs, and they are both running 2 GB, but you can also give them 4 GB if you want. For the virtual network, there's a few different ways we can do this, but in this video we created a virtual NAT. I'm also going to show you how we use this interface in the Linux Mint. So if we start this machine, first thing we want to know, I would like to show you guys is how we created a bridge interface, because the routers are going to want to process the frames as layer 2 Ethernet frames. So in order to achieve this, what we do is that we take the NIC from our virtual Linux machine, and we create a bridge interface. So here we can take a look at how I set up the network on the Linux VM. The main thing to see is that I took the virtual NIC and I created a bridge interface which is going to take that virtual NIC, which is attributed to the NAT network that we created with VirtualBox. I'm going to create a separate network. So this one is going to take a 192.168.5 subnet. But I'm still going to give that VM internet access by creating another bridge interface, which in return will get a DHCP address, and that will link back to the NAT network and get access to the internet via that interface. The next thing we want to do in order to simulate the 7200 images is that we are going to use Dynameps, which is a Cisco emulator. And then we're going to be using as well Dynagen, and that's really the front end for Dynameps, the way we can configure it. So first thing we want to do is install those two. So we need two different things at this point. We need the image of the C7200. So this is usually a bin image, which I have right here on the desktop. And then we'll need a config file for Dynagen. I'll post the contents of the config file on the description. But over here, the only thing you might have to change is the location of where we're going to be putting the Dynameps images and the image of the router as well. For this demonstration, we're going to have two routers. We're going to be working with router R1, and we're going to be linking it to a tap interface, which we'll create in a little bit, and that tap interface will link to that bridge. And then we'll have another router named R2, and in this case again we'll create another tap interface to that same bridge. I'll create a directory just in the folder just to make things easier, and I call it C7200. So again, make sure that the config file is pointing to that same directory folder for the image of the router. Now we need to run a few commands in terms of creating the tap interfaces, but also starting the Dynameps and Dynagen instances. So for this, we can enter a few commands manually, but just for the purpose of making things easier, there is a script that does exist that does make things easier. So we'll go over what this script does. So if we look over here, the first thing we need to see is that It's going to kill Dynamis and Dynagen just in case they were running in the first place, so that doesn't create a conflict. Then we start the Dynamips emulator on the TCP port 2000. After this, what we're doing is that we're creating two tap interfaces, and we're going to link those tap interfaces to the bridge interface that we created on that 192.168.5 subnet. Then we are bringing those tap interfaces up, and essentially after this we are starting Dynagen on that config that we have created in the C7200 folder over here, and then we're going to be starting the R1 router and the R2 router. By the way, when it comes to the routers, if we look at the config file that we created previously, we made sure that the console, so this is really the telnet connection, is going to be attributed to the port 2521 for R1, but also port 2522 for R2. So this is how we're going to get access to those routers. So at this point, what we can do is just start the script. Over here it opens up a window. This is really a window for Dynagen if we want to start or stop the routers, but as you could see from the script, we have already started the routers. We can open another console window, and we can telnet into the routers themselves. So for this, we'll telnet locally, so telnet localhost, and again, if we want to telnet into R1, we're going to use the port 2521. The first thing that it is going to ask us is if we wanted to enter the additional configuration. We don't want to do this. We're just going to do this manually. And while this is starting, we can create another console window and do the same thing, but with R2. So telnet localhost, and this time the port number is 2522. Once we're into the router, we can go and change the host name, so we'll need to do this in configuration of the terminal. Alright, now what we want to do is that as per our config for Dynagen, what we did do is that we attributed those tap interfaces to our interface F00 on our routers. Now that we can process layer 2 frames on that interface, we're going to we're going to add an IP address which is going to be part of the same subnet that we have created earlier, and that is IP address. So for the first router, I'll just give it an IP of 5.3 and make sure I assign the subnet mask, and then we're going to no-shut that interface to bring it up. And same thing over here, we're going to go to interface 00, and then we're going to add an IP address. So for those two routers, just to make things easier, we are going to make it part of the same subnet. And for that one, I'll give it an address of .4. Next thing is that we're going to do is we're going to enable the telephony service. Next thing we want to do is specify the number of phones that we're going to be dealing with. In this case, we're only dealing with one phone, but just to make things easier, I'll say that we can have a maximum of 10 phones. The next thing we wanted to do is tell the telephone what's going to be the source address for the telephones themselves. So in our case, this is the 5.3, and we're going to give it a port of 2000. Next up, we assign the maximum number of extension numbers, extension lines. In this case, it's 25. What we can do as well to make things easier is that we can assign a system message. For the first one, I'll just give it router 1, and I'll give it the name router 1 VoIP. And after this, we want to create the CNF files. What this will do is that it will create the config files for the phones to get. On the router R2, we'll really want to do the same thing, but obviously change the source address to 5.4. After we've set up router 2 in the same fashion, we're going to go back to R1, and this time we're going to create the phones, but also the phone directory numbers, and we're also going to create the dial peer so that we can phone other numbers on a different router. So for creating the phones, what we want to do first is just create the numbers. So here we're going to create our first directory number for router 1. So I'll just call it number 1 just because it's the first one. And then I'm going to give it a number. So for the purpose of this demonstration, we'll just give it a number, let's say 7813. And at this point we created our directory number, and now we can create our first phone as well. So we're going to call this one phone ephone1 since it's the first phone. And then we want to assign the MAC address. In order to create our first phone, what we want to do is go onto one of our Windows VM, and the first thing we need to do before we set up the Cisco IP communicator is make sure that it is on the same subnet as the router that we just created. So in order to do this, we just need to assign the IP address. So we just go into the NIC settings, and for this one I'm going to be giving it an IP address of 5.10. And again, for the same thing for the Windows 2, the other Windows 10 VM, I'm going to be doing the same thing and giving it an IP address on the same subnet, and this time I'm going to give it an IP address of 5.20. Once this is done, what we want to do is get the MAC address of the Cisco phone. So if we go into the settings of the Cisco phone, we have a tab for the network settings where we can specify the TFTP server. Before we do this though, we can get the MAC address, which is over here, which is really the numbers after the SEP. So we'll want to select this and copy it. Over here we can assign the TFTP server, which is really the source address for our CME router. So in the first one, it is 5.3. We can go back to our Linux VM into the router R1, and here we can paste the MAC address. We do need to format it in the same way that Cisco wants us to format it, which is just putting colons after every 4 digit. Once we've put the MAC address over here, we can continue setting up the phone before it gets attributed to us. And over here, what we're going to do is assign the directory number to our phone. We can assign this to button 1, which will be the default one, but for the purpose of this demonstration, we'll assign it to the second button. So it will be 2, and then our directory number that we created was the first one. So here we put 1. At this point, what we can do is restart it, but since the phone is not on the network yet, we can just apply this. So we go back to our first VM, and we can press OK, and here we can see with the system message that we are indeed connected to the right router. We can also see that the second button has been linked to our directory number 7813, and as we can see here, the phone has been registered to the router. Now going to R2, we do really the same thing, but this time give it a slightly different number. For this one, I'm going to be giving it a number of 7913. Once both phones have been successfully linked to the appropriate routers, we should be able to see that both phones have different phone numbers attributed on their screen. Now, in order for the phones to be able to call each other, we need to create dial peers. The command itself are simple, so I'll just show you how to do this over here. So we want to create dial peers. So here we create our first dial peer, which is called number 1. And then we want to specify what is going to be the destination pattern. And for this case, we'll just say that the phone numbers on the second router will all start by 79. So what we can do over here is we can create a dial pattern with the numbers 79 and then dot dot, so it could be any 2 digits after the 7900 numbers. What we need to do is also assign what is going to be how we can reach that those numbers, and over here it's going to be working with an IPv4 address, so we're going to be assigning the IP address of the second router, which is 5.4. We need to be able to do the same thing on the other phone. Once we have created the dial peers for each of the routers, we can test this out by simply calling the phones. So from the first router, I'm going to be calling from the phone number 7813, so I'll just need to pick up the line on that one. And then all I need to do is call the number on the other phone. And over here we can see that the dial peer has successfully routed, and now we can see that both phones essentially can call each other. And with this, we have successfully created a virtualized environment with CME routers that are going to be able to provide telephony services to the Cisco phones, and you'll be able to essentially have more experience regarding the configuration of this type of environment.